There are several factors that can affect the rate of a reaction. One factor is the concentration of a reactant. Most chemical reactions proceed faster when the concentration of one of the reactants is increased. For example, let's look at the reaction of solid zinc with hydrochloric acid to form an aqueous solution of zinc chloride and hydrogen gas. Let's say we put a piece of zinc metal, so I'll go ahead and draw in the piece of zinc metal in here, in a flask that contains 3 molar hydrochloric acid. So in our flask here, we have a solution of 3 molar hydrochloric acid. As the reaction proceeds, hydrogen gas is formed. So we could monitor the rate of this reaction by observing the amount of hydrogen gas bubbles that are coming out of the flask. Let's say that we repeat the experiment. This time, instead of using 3 molar hydrochloric acid, we're going to use 6 molar hydrochloric acid. So we've increased the concentration of our hydrochloric acid solution. This time, when we add our piece of solid zinc to our 6 molar hydrochloric acid solution, we would observe more hydrogen gas bubbles coming out of our flask. So we have increased the concentration of one of our reactants, hydrochloric acid, and we've observed an increase in the rate of the reaction. As the concentration of hydrochloric acid increases, there are more acid particles to collide with the piece of zinc. And therefore, as the concentration of hydrochloric acid goes up, the frequency of collisions increase and the rate of the reaction increases. Let's use this same reaction to talk about another factor that affects the rate of reaction, and that factor is surface area. We've already reacted a piece of solid zinc with hydrochloric acid. We could use 3 molar hydrochloric acid again, and we saw some bubbles come off of the piece of zinc, indicating that hydrogen gas was produced. This time, let's try breaking the piece of zinc into smaller pieces. So instead of using one large piece of zinc, here we have a bunch of small pieces of zinc, and if we were to do the experiment again with 3 molar hydrochloric acid, this time we would see more bubbles of hydrogen gas coming off of those small pieces of zinc. So we have increased the surface area of the solid, and we observed an increase in the rate of the reaction. When we had only one piece of zinc, the rate of the reaction was limited by the surface area of this one piece. Therefore, by breaking it up into smaller pieces, we were able to increase the rate of the reaction. Temperature is another factor that can affect the rate of a reaction. So let's say on the left we have a glow stick in a flask that contains some cold water. And the glow stick, let's say the glow stick is already glowing here, so let's draw in this color here for our glow stick. The glow from a glow stick comes from a chemical reaction. And if we were to increase the temperature, so let's say we heated this flask on the left, so we increase the temperature, we would observe the glow to get stronger. So let's go ahead and draw in here a more vibrant glow coming from our glow stick. So increasing the temperature must have increased the rate of the reaction. The reason increasing the temperature increases the rate of the reaction in general is because increasing temperature means the molecules are moving faster, and therefore the molecules are colliding with each other with greater frequency and with greater force, which increases the rate of the reaction. A catalyst is another factor that can affect the rate of a reaction. Let's look at the balanced equation for the decomposition of hydrogen peroxide, which turns into water and oxygen. And let's say in our flask on the left, we have a solution of hydrogen peroxide. The hydrogen peroxide is decomposing at room temperature, but the reaction proceeds so slowly that we don't see it even happening. We can speed up the reaction by adding a catalyst. Let's say we have an aqueous solution of potassium iodide in our beaker here, and we pour the solution of potassium iodide into our flask containing the hydrogen peroxide. The addition of the iodide ion as a catalyst causes the decomposition of hydrogen peroxide to occur very quickly, and we would see a huge plume of gas come out of the reaction flask. So the addition of a catalyst, in this case it was the iodide anion, increased the rate of the reaction. A catalyst increases the rate of reaction by affecting the kinds of collisions that occur between particles, and a catalyst increases the rate of reaction without being used up.